Hello friends, the other day we were concentrating on area of triangle of mensuration. Area of triangle, and I told you earlier that we will go through some critical and tricky sums. So for today, here is a sum. A triangle ABC, it is isosceles, and here AB equal to AC. AB equal to AC, and both of them is 20 centimeter only. And another clue is there, that is the equal sides, in between the equal sides the angle is 45 degree. That is the given clue, and we have to find out the area of the triangle ABC. And I told you earlier that there is one generalized formula, half into base into height, and another one was Heron's formula, that means involving the semi-perimeter, S into S minus A, S minus B, S minus C. So whenever we have the three sides of a triangle, then it is convenient for us to deduct the value of base, and easily we can find out the area of the triangle. But in this type of sums where the three sides are not given, here the two sides only given, so it is difficult to use the Heron's formula because the number of variables are much more. So we can use the generalized formula, that was half into base into height. And what I told additionally, that the height, how can you recognize the height of a triangle? I told you that whenever and wherever in any triangle you see a perpendicular, either it is given or you draw for your convenience, this perpendicular is to be taken as the height of the triangle. And the perpendicular, wherever it falls, on what side, that is to be taken as the base. That means the base holds the perpendicular, so the perpendicular is the height and the base is the base. So that is the formula. So here we also need, because what we need to prove is area of ABC. Deduct rather. What is the area of ABC? And given clues, angle BAC, that is the angle which holds the two equal sides equal to 45 degree, and the equal sides AB and AC both 20 centimeter only. That is given, and we have to deduct this area of the triangle ABC. And whenever is area needed, I told you just now that we need height and base. Height and base for this type of sums, height and base. So in this triangle we can't see any perpendicular. So where from we get the height of the triangle? That's why we need to draw a perpendicular on this side. Let it be BD. So BD is the perpendicular drawn on AC. And you see that this is 90 degree as I draw a perpendicular over here. So the ADB is 90 degree and BAD is already given 45 degree. So ABD is also 45 degree, because we know that a triangles have three angles, and the sum of the total of a triangle is 180 degree. So here 90 plus 45 degree, 135 degree. 135 degree if you deduct, you can get 45 degree. So the ABD is also 45. As we see, BAD was given 45. Coincidentally, the ABD is also 45 degree, and whenever we see the angles of a triangles are equal, then we can easily say that it is isosceles, because the sides which holds these angles, they are always equal. So we can say if it is 45 degree, then BD equal to AD. So in triangle ABD, BD equal to AD, because since angle BAD equal to angle ABD equal to 45 degree. So obviously BD equal to AD. This side equal to this side. And why? The question is, why are you concentrating on this triangle? Because this triangle includes the BD. This triangle includes the BD. And what we require to deduct the area of ABC. And what area of ABC needs? Base and height. Half into base and height. So base is AC. What the perpendicular falls, it is base. I have told several times. Where the perpendicular falls, it is the base. So AC is 20. We know it already. AC is 20. So, and what is unknown to us is BD. So BD is included in this triangle ABD. So whatever we have done to deduct the value of BD only. So this is a right angle triangle ABD, because D angle is right angle, AD is perpendicular, and AB is hypotenuse. So from right angle triangle ABD, for right angle triangle, the universally accepted formula, you know all Pythagoras theorem. The theorem, what the theorem says? It says that the square of the hypotenuse is equal to square of the base plus square of the perpendicular. It is universally accepted Pythagoras theorem. So from applying Pythagoras theorem, we get here the AB is the hypotenuse, because hypotenuse is the opposite to the 90 degree angle. So AB square equal to AD square plus BD square. AB square equal to AD square plus BD square. Or AB value we all know 20. So 20 square equal to AD we don't know, BD also we don't know. But we know that AD equal to BD. At the very beginning we found that ABD equal to 45 degree and BAD was already given 45 degree. That is, it was isosceles triangle, and the sides of the isosceles triangle AD equal to BD. So we can say that, and what we need to find out the length of the BD. So we would easily replace AD by BD. So BD square plus BD square. So AD square equal to BD square, and already there was a BD square. So 2 BD square equal to 20 square 400, or BD equal to 200 BD square, or BD square समान 200, or BD equal to root over 200, that means 10 root 2 centimeter. I think it is clear. From Pythagoras theorem, on this triangle ABD, right angle triangle, AD square equal to AD square plus BD square, And what we need for our purpose to find the area of ABC, we need BD, not AD. We need BD. So that's why we have replaced AD by BD, because we know BD equal to AD. So BD square plus BD square, 2BD square equal to 20 into 20, 400. So BD equal to 200 and BD square equal to 200, I'm sorry. And BD equal to root over 200, that means 10 root 2 centimeter. Now it is very easy, you easily can find the area of ABC equal to half into what is the base AC 20 and what is the height 10 root 2, what we found now. So 100 root 2 is the area of square centimeter, area of the triangle ABC. I once again repeat, there is a triangle ABC isosceles and each of the equal sides were 20 centimeter and the angle holding these equal sides were 45 degree. And what you are required to prove is, required to deduct is the area of triangle ABC. And for these, following the formula, we need some height. That's why we have drawn a perpendicular BD on the side ABC. So BD may be the height and AC may be the base of the triangle, but height was unknown to us. That's why we have used this smaller triangle ABD, which was also a right angle triangle, and by calculating we found that ABD was 45 degree and it was already 45 degree. That means it was also isosceles triangle, and that's why AD equal to BD. Now from this triangle, if we use the Pythagoras theorem, that means hypotenuse square AB square equal to base square AD square plus perpendicular square BD square. AB we know it was 20, it was given, but neither we know either AD nor we know BD, but we know BD equal to AD. So what we need here, BD. I have not any interest about the value of AD. We need BD. So we can replace here AD by putting the BD. So BD square already there, and another BD square, 2BD square equal to 400, BD square equal to 200, BD equal to 10 root 2 centimeter. Now it is very easy to find the area of the triangle. Equal to half into base was already given, AC 20 centimeter, and BD, that means the height was already deducted, 10 root 2 equal to 100 root 2 square centimeter. Now till now it was not very complicated, but the complications arises when these sums only a bit different. Where it is again it was ABC, again it was AB equal to AC, again it was 20 centimeter each, but the problem here was the angle holding was 30 degree, not 45 degree. 30 degree. The procedure is also same here, because here is also what we require to deduct is area of ABC. And what is given, as I told, angle BAC equal to 30 degree and AB equal to AC equal to 20 centimeter each. And as we told that for deducting the area of ABC, we need base into height. So if we draw a triangle, then BD may be the height and AC is the base. So BD, we have drawn a triangle. Now the question is, it is 90 degree and we are again concentrating on this BAD triangle because BD is included there and we need BD. Because if we find out BD, then we can find the area of the triangle very easily by putting AC base half into AC into BD. But here the problem is that here it is not equal. it is 90 plus 30, that means 120 degree. So 180 minus 120 equal to 60 degree here. The angle is 60 degree. Here the angle is 60 degree. It is also a right angle triangle because I have drawn perpendicular over here. So here we use a theorem which says that in a right angle triangle, in any right angle triangle, the angle, if the one of the angle is 30 degree, if one of the angle is 30 degree, then obviously the another angle will be 60 degree because it is mathematically proved. And then the theorem says that the side opposite to the 90 degree, that is what is called hypotenuse. Hypotenuse should be twice the BD, this side. And what is this? The side opposite to the 30 degree angle. So the theorem says the side opposite to the 30 degree angle is half of the hypotenuse, or the hypotenuse is twice the side opposite to the 30 degree angle. Again I repeat, in any right angle triangle where the one of the angle is 30 degree, 90 degree was already one because it is 90 right angle. So 90 plus 30, 120, then another angle obviously be 60 degree. In that type of triangle, it is universally accepted that the hypotenuse is half of this side opposite to the angle 30 degree, or the opposite to the angle 30 degree side is, hypotenuse should be twice the side of the triangle which is opposite to the angle 30 degree. And we can say that the side opposite to the 30 degree angle is half of the hypotenuse. So here BD is the side opposite to the angle 30 degree. BD is side opposite to angle 30 degree. So it should be half of the hypotenuse. So BD equal to half AB. It is theorem for any right angle triangle containing a 30 degree angle. That means 120, 90 plus 30, 120, another should be 60. So BD equal to half AB. And conversely, we can say also that it can also be said that if any right angle triangle, if the one angle is 60 degree also, because then the another angle would be 30 degree. That means the right angle triangle which contains 90, 30, 60 degrees of angle, then this is true that hypotenuse equal to always half of the side opposite to the 30 degree angle. So BD equal to half of AB. That means we know AB's value 20. So BD equal to 10 centimeter. So BD equal to 10 centimeter. That's so the sum is done. Now the BD was the problem. BD. So area of ABC equal to half into base AC, because the BD falls on AC. AC is 20 and BD we have just find out that it is 10. So 100 square centimeter. So the two terms sums were almost same, but the difference was in the amount of triangle. It was 45 on the other sum what I solved earlier, and for that sum it was 30 degree. That means this angle was 60 degree. So here the theorem lies, universally accepted theorem, that wherever a right angle triangle have 30-60 degree angles, so then the hypotenuse will be double the sides of the 30 opposite to the 30 degree angle. So by applying we easily find out the value of BD here. BD equal to half of AB, so 10. 20 half 10. And now we can apply the formula also. So that's all for today. See you next.